Statistics, welcome to lesson 5.6. We're going to talk about the standard normal distribution. We're going to do this stuff. It's going to be cool. Maybe. All right. Normal distribution is really important. It helps us to calculate probabilities of events occurring if those events follow a normal distribution. If you were to look at the distribution, the shape of the graph, and it looks like a bell-shaped curve, right? That it's fairly symmetric. So that's why we need it. Let's talk about the standard normal distribution. This is what it looks like, and it has the 68, 95, 99.7 rule. I actually like to call that, man, I wish these all fit on the one page. I'll refer to this as the empirical, because it's easier to say. Tells you that 68% of data or observations are within 1 standard deviation of your mean, 95% are within 2 standard deviations of your mean, and 99.7 are within 3 standard deviations of your mean. So, if we're looking at a standard normal distribution, your mean is 0. Oh, that's a terrible way to write that. So right here, this is mean, right, at 0, okay? And this is saying this is 1 standard deviation above the mean. Right, which means that this guy is pointing at, right, so, and -1 corresponds to 1 standard deviation below the mean. So what your 68, 95, 99.7 rule is telling you is that 68% of your data is in there from 2 standard deviation. That 95% of your data is here. And right in here is 99.7%. So there you go. Your standard normal distribution tells you how many standard deviations from the mean above or below a particular data point is. And then we can find how unusual that is sometimes using this empirical rule. All right. That's pretty much what I was just saying. We can find a z-value, so a standardized value, right? So these guys are happening in the real world, right? So these are actual values. This right here tells you how many standard deviations from the mean. That a certain point is x. Okay, this x. And I'm talking about that. Okay. So that formula tells us how many standard deviations from the mean a particular data value is. That value x. So I gave you all table A. This is what we're talking about. So we can find an area underneath our normal curve using table A. So we'll get a z value, a standardized value, we're using that formula that I just showed you. And then you'll look on the leftmost column on that, and you'll be looking for z values. We'll match those. We'll look on the inside, and that's going to give us a probability, an area under the curve, which is a proportion. So what if we wanted to find the proportion of observations from the standard normal distribution that are less than 0.81. So so someone calculated z equals x minus mu divided by your standard deviation and got whatever those numbers were, got 0.81 as a z value, right? So I'll show you on your table how to find that. So we're going to look for 0.81 on this table. So I'm looking at this column. So the leftmost column, and I'm looking for 0.8. I found 0.8. Okay, right there. And then I'm going to match it with the 0.81. Okay, on the top. And then we're going to find where those two intersect. 0.81 gives a probability of 0.791. Okay, and that's what we got there. That's what we got there. Okay. All right, I'm going to actually draw. I like this picture, right? This is the this shaded region right here is your area under the curve. It's the same thing as the probability or the proportion of values that fall below it. We can also draw a regular normal distribution of this. Except for that I don't know what it means. So no, I can't. I got it. All right, so we're going to be getting a z value from some statistic, and we're going to find the area under the curve that corresponds to that z value. Let's try it again. What if I was looking for the z-score that has 90% of the area to the left? Okay, so now I'm going to actually work backwards. Okay, if I wanted to find a z-score for that, I'll go to my table. And now I'm looking in here, in the like main body of it. And I'm looking for a number that's closest to 0.9, right? If we're looking for 90% value that's closest to 0.9, it looks like that one is the closest, right? This one is 0.0015 above 0.9, but this one is only 0.003 below, right? So this one is close, but not as close, right? This one is 0.0015 above 0.9. This one is 0.003 below. So this one is closer. So then what we'll do to find what the z-score is we'll look at this row, this column, and this one, right? And that's going to tell me that the z-score is 0.128. So 1.28. Okay. So that's how we're going to use our table. So we can find a z-score and then find an area. Or if we're asked to find a z-score that corresponds to an area, then we start from the inside and work our way out. We're going to do more of an example like this, okay? All right, that's not everything else. Okay. Let's actually do an example. All right. In baseball, a player's batting average is the proportion of times that the player gets a hit out of his total number of times at bat. Suppose we select a Major League Baseball player at random. The random variable x equals the player's batting average can be modeled by a normal distribution with a mean equal to mu equal to 0.261 and a standard deviation sigma equals 0.034. Use the 68, 95, 99%, 99.7% rule to approximate the probability that a randomly selected player has a batting average greater than 0.329. Okay, let's see that first. All right, so let's do this. First thing I'm going to do is I'm going to actually draw the standard normal distribution here. All right. All right, I'm going to draw this thing. Plus, that's going to give it. So I'm going to draw a picture of this. It's normally distributed. And it says that the mean of these is 0.261. And maybe I want to make a bigger picture. I think I do. You over there. Okay. All right. That's better. I need a little more room. Okay. So this is our mean. The middle is 0.261, right? We're going to draw one standard deviation above, below, one above, two standard deviations below and above, and then three standard deviations above and below. And the way that I'm going to get the numbers that correspond to this is I'm just going to add 0.034 to 0.261, and I'm going to subtract it, right? It's going to tell me one above and one below. So 0.261 plus 0.034. This tells me that this value, one standard deviation above, is at 0.295. I'm going to go ahead and take 0.261 and subtract 0.034. And that's going to tell me that this value here, one standard deviation below, is 0.227. Okay, I'm gonna keep adding till I find this number. Okay, all right. So let's go. So we're gonna keep adding, right? I'm gonna actually add one more standard deviation to 0.295, and I'm adding to 0.295, right? We're gonna do one more standard deviation above 0.034, and I get 0.329. I'm just gonna complete the picture and subtract one standard deviation from 0.227. That's 0.193. I'm going to draw the whole thing, right? So this is where your mean is. That's one standard deviation. That's one standard deviation below. This is two standard deviations below, two standard deviations above. Now let's calculate three standard deviations above and three standard deviations below. I don't think we need it, but this is a complete picture of the distribution of batting averages, the normal distribution of batting averages. So 0.329 plus 0.034. So three standard deviations of the mean is a batting average of 0.363. And three standard deviations below is 0.193 minus that is 0.159. So there's the whole distribution. If you were asked to draw the distribution of batting averages, this would be a good answer. So going a little bit above and beyond, we're going to use this rule now to approximate the probability that we're greater than 0.329. So in other words, we need this region. Okay, that's what we're looking for. All right, so I'm going to draw another picture. Here's the other picture. Here we go. Right? If we're looking at our empirical rule, right? 0 is here, and our standard normal distribution. We're looking at 1, 2 standard deviations above, right? We know that in here, right, is 95%. Yeah? Which means that this one plus this one have to add to 5%, right? We said that the area under the curve has to be equal to 1. So if that's true, right, if this one plus this one have to add to 5%, then this must be 0.025. And this one must be 0.025. Or, sorry, we're doing percents. That's probably confusing. This is 2.5% and 2.5%. Sorry. Better. I switched from percents to decimals, right? And what's that probability then? Well, these areas match, right? So that means that the probability is, so let's use some notation here. The probability that x is greater than 0.329 is equal to point, we're gonna turn this into a decimal. All right, how about the probability that is between 0.193, we'll leave at this one, and 0.295? So that is from here to here, right? All right, so we got to do a little weird geometry with this, right? We know that 1 standard deviation above and 1 standard deviation below has 68%, right? But we need to add this little piece, right? So that's 1 standard deviation, 1 standard deviation. This one, this side goes to 2 standard deviations below the mean. So I'm actually going to draw you a cool picture that's going to help you with these. That's going to actually break down all of these probabilities. So here we go. The empirical rule picture with a lot more information. This picture is going to be so important. If you won't have it handy, then everything's going to be much harder. This picture is going to make it so much easier. I'm going to break up each one of these into percentages for you. And that is going to make using the empirical rule. Okay. So 34% is in here. 34% is in here. Right, that's easy. It's just 68. They're the same distance away. So 68 divided by 2. All right. Well, in between. All right. So in between here and here is 95%, right? So if I subtract what's in the middle, I get. Okay, brain dead today. 27, and then that's going to be divided by 2. 13.5. So what does that mean? That means that in here, we have 13.5, and then this one is 13.5 as well. 1, 2, 3. All right, we said that between here and here is 99.7, right? So then I'll take the 99.7 minus the 95 or 4.7. That's going to give us what's in that little area. If I divide it by 2, so this one is 2.35. This one is 2.35. And what's left is 0.3 divided by 2. So this is, sorry, 0.03 divided by 2. This is 0.015. And this one is 0.015. And that's all your areas in percentages. Yeah. All right, so that makes it much easier for us to answer the question, because now all I need to do is add this one, and that one, right? Let's look back at the top. Right, what we're trying to find is actually all that, what's shaded in there, yeah? And we just said in our picture that this one is 34. This one is 34%. And we said that that last area was 13.5. So this one is 13.5. We'll add them. And we'll say that this is equal to what? 68 plus 13.5, 81.5. Or we could say that probability is equal to 0.81. All right, let's do the next one. We're going to be calculating some z-scores. And then finding a probability. All right. All right, so in order to answer number 2, first thing I need to do is recall my mean is 0.261, my standard deviation is 0.034. So, equals 0.261, standard deviation 0.034. All right, so what's the probability that the z-score is between 0.2058 and 0.179? Right, so I'm going to show you how to do this the long way, and then I'll show you how to do it with the calculator. So first thing I would do is I have to calculate 2 z-scores. Oh. All right, this must be a typo. That's got to be a typo. That's not even a real thing. I believe we need to say 2.58. All right. So we're going to draw a standard normal distribution for this. For the standard normal distribution, the mean is 0 in the middle, right? And then one standard deviation above the mean is about here. One standard deviation below the mean is about here. 2 standard deviations above the mean is about there. 2 below is here. 3 below there. My picture kind of sucks. Okay. We're just wanting to point out where these things are. So 2.58 is right there. And 1.79 is about there. So what we're looking for is the area of this shaded region. We can get that from our calculator. Or we can do it with our table. Let's go ahead and go to the calculator and show you guys the trick to do this. All right, so we're gonna go to our handy dandy calculator for this, and you could use this now on the previous two examples. This works really nicely. We're gonna get out our calculator, and we're going to calculate normal CDF. So the way that I'm gonna do this is I'm gonna hit second vars, and I'm gonna go to normal CDF. I'll look at my picture and see that my lower bound is this 1.79. My upper bound is 2.58, right? That's indicated here on the picture, right? On the low side, we have 1.79. And on our upper side here, we've got, I really shaded way too high there. That one is 2.58. All right, so let's put that in our calculators. Lower bound was 1.79, 2.5. And our upper bound then is 2.58. We do, since it's standard normal distribution, the mean is 0 and the standard deviation is 1. And we get a value of about 0.04. And we'll say that's the probability that Z is between 1.79 and 2.58. That's about 0.04. All right, for this one, we're talking about batting averages, so we need to keep in mind that we have this mean and we have this standard deviation. I'm going to do this one with our calculator too. We could do it from the table and have to do some algebra, but that's a pain. Instead, what I'm going to do is I'm going to hit second, vars again, and I'm going to go to inverse norm. Okay, inverse norm. The area I'm looking for is 0.4. I wanted 40%. And now I'm going to have to enter our mean from the problem of 0.261. And our standard deviation of 0.034. We are looking for the area below, so we'll keep it to the left. Is that correct? It was looking for that? Greater than. Ooh, so we need to do right. So I'll go up and turn this to right. Oh, no. Enter. And that's going to give me 0.270. And I'm going to draw this for you. So drawing this picture, our mean is at 0.261, right? And we're looking for a value that has 45%. Dang it, I answered the wrong thing. 45% above. Let's re-put that in our calculator. This should actually be, change this to 0.45, and that will give us a proper value. All right, so 0.265. Let's draw a picture of what we just found. So this is 0.265. And what we found was the value that has an area of 0.45. All right, well, that's all I have to say about that. We got quite a few things done today. Thanks, Everyday Stats. I hope you're having a beautiful day, and if you're not, I hope it gets a lot better. Take care.